Hi everyone, I'm Pierre for Morales and welcome back to this series of videos where together we learn how to code in Solidity. We're back today in our blind auction. This is part 2 of the video. If you haven't watched the first one, you absolutely have to watch it and then come back here. So we'll jump straight to it. What we did last time is basically explain what we're going to be doing. We set up just the structure of our contract with the variables at the top that we have already declared. As well as just the one event that will be logged when the auction is ended. We've marked that here we're going to be keeping our modifiers and below that all of our functions. And today we're going to start writing all of these. And we should start straight away with our modifiers. So we're going to have two modifiers. The first one is going to be called only before. And it's going to allow us to just make sure that whatever function happens will be before this date only, this time only. So uint, and we're going to call it time. That's the argument that it's going to take. And this modifier is simply going to require that the current time, so block.timestamp, is smaller than time. And we're just going to return also this, like this. Okay, so that's our first modifier done. And it'll make sure that the current time is smaller than the time that is passed in the argument. And the other one that we're going to have is also going to be, so modifier. And this one is going to be only after. And it'll be, you guessed it, the opposite of this one. And it's also going to take time. And it's going to require, maybe let's add some spaces here just to make it a bit more readable. And 1 second, because I realize right here, this is what we need. So we're going to require also that block.timestamp this time greater than the time that is passed. Okay. Remember, the underscore always has to be passed, added at the end of your modifier. And this is what it will allow to take whatever function comes next. Okay, nice. So that's our two modifiers. Only two of them to check the time before, after, just make sure we're within this. Then we go into our constructor. So the constructor, again, is when you deploy the contract, the first time it is actually run, the constructor function is called in order to declare whatever you want, to do whatever you want. In our case, we're going to be taking 3 arguments, and we're going to be already declaring certain variables and adding some values there. And we're going to be looking at the beneficiary, bidding end, and reveal end, right? So these 3 variables that we declared last time. So how we're going to do, first off, here we're going to add some arguments, and I'm going to do it like this. It'll be a bit neater. So uint, and we're going to call it bidding time. Then second argument will be also uint, and we're going to call it reveal time. And finally, we're going to take an address payable, and this will be the address of our beneficiary. So these are the 3 arguments that we will have to pass when we call when we deploy our contract. Okay. So constructor, and now within this constructor, what we're going to do is, 1 sec, let's make this all neat. Okay, here we go. We're going to now declare that our variable beneficiary that we declared up here equals to beneficiary. After that, we're going to say that our bidding end, equals, so the current time block.timestamp plus the bidding time that we passed here, right? So what we're going to say in bidding end, basically, when we call the function for bidding time, is that we're simply going to set how long we want the bidding to be available for in seconds. So, 60 seconds. And then reveal end, we're going to count it as the bidding end plus whatever reveal time was passed here. So if we put 60 seconds for the bidding time, the bidding will be available for 60 seconds. And if we also add 60 seconds, then the reveal end will be 60 seconds on top of the bidding end. So there will be 60 seconds to reveal all of the bids and transfer everything to the beneficiary. So that's our constructor. Quite simple. You see, just 3 arguments, and it populates 3 variables. Then we're going to move on to the more simple functions that we have here at the bottom, which are so the withdraw function. This one we've done a very similar one in the past when we did our first auction, and we're just going to come here and populate it. So we want this function to be public, so it's accessible from outside the contract. And we're going to first declare a variable that will be uint amount, and this variable is simply going to grab the value pending returns using the address of the sender. Okay, so let's break down a few things. What we declared in the last video was this mapping here, which is pending returns. And in this one, we're gonna add simply all of the addresses of people that are not winners of the auction, and what amount is supposed to be returned to them, so that they can simply come here and withdraw their amount themselves. And the first thing we need to do is, of course, get the amount that is pending return for their address. So we just stock it in this variable amount. And after that, we're just going to make a simple verification where we check that if the amount is greater than 0, then what we're going to do is, first thing important always is we're going to say pending returns. I forgot an S here actually. Pending returns, and we're going to get the address of the sender. We're going to set this to 0. First thing we do, because if it's greater than 0, we're of course going to transfer this amount back to the sender, whatever is owed to him. But before doing so, we want to make sure that we set it to 0, so he won't be able to call this function again. So important, we do it straight away, first thing. And then we're going to just simply say that declare his address as payable. So that's what we do here. His address, we put it within this payable function, and we're going to transfer the amount that is the variable that we set here. Quite simple. Withdraw works this way. Then we're going to create a function that allows to bid. So we have 2 things here for the bid, because the bid is going to be quite simple, and maybe we can do it right now. We're going to start with this, and then I'll move back. So bid basically is going to take a hash value, and this hash value is going to be generated through this function. Yeah, and so okay, here what we're going to do is we're going to let the user input a uint that is going to be value, and a boolean that is going to be fake. Right, so that's the names of these variables. And so this function will be public. It's only going to be view, and we're going to make it return bytes 32 object. So bytes 32 is a hash. So what we're going to do is use these values to produce a hash that will be returned to us with this object here that we declared. Now, very simple. You see, we won't need anything else. We can go straight away to the return statement, and we're going to use this function, Ketzak256. I'm not sure how you would actually pronounce that. And ABI dot encode fact, and we're going to call value fake. So I'm not going to dig deep into exactly how this function works. I think maybe we'll do this in the future when we'll get back to some theory. I think this maybe is the best place. But basically, if you take just this value and you take this as your function, it takes 2 arguments. I mean, it can take multiple arguments, but basically whatever arguments you pass here, whatever values you pass, they're going to be combined into one hash. And will give us this bytes 32 object that we can then use however we want. Now, why are we doing this here this way? The bid doesn't really happen. There won't be transfers until the end of the auction. Because if we do transfers before that, then this will be publicly available information, and we reveal this, and it no longer is a blind auction. So what we do though is we're going to take these values, and the user is going to provide what amount he wants to actually bid. And then he's going to add a statement saying whether it's a true or a false bid. This is just something that often can be available in blind auctions, just to add a bit of a complexity to the bid. And it has to be false for the transaction, the bid, to be considered a true bid. Why? Because fake, well, true would mean yes, it is fake. False, no, it is not fake. And so we get this object back. And with this hash, we can then actually place the bid. And then we'll be able to view these bids, but without knowing the details of it. So let's take a look. Now, bid is the function that will take one argument, and the argument will be bytes 32. And it's going to take blinded bid. This will be the argument. Now, bytes 32 means that once we get our value from this function, we're going to use it to place our bid, because what we want to actually register is the hash value of the bid that we can then go and verify. And we'll see this later. This will be part of our reveal function. I'll explain it then. Okay, so this function is, of course, public and is payable. And this can only be done before the end of the bidding end. So this is when we're going to use our modifier only before. So payable, and here I declare only before, and we're going to use our bidding end, which, of course, if you remember, we declared here in our constructor. Okay, now we can move on. So what this function does is quite simple. It's going to simply add a value to our mapping bids. That is a mapping of, for each address, a list of bids. So bids, and we're going to add a new value for message.sender. So whoever is doing placing the bid. And we're going to push, which allows us to add a new value at the end of the list of bids for this address. So we're going to add a value at the end that will be, wrong parentheses, that will be, of course, a bid. And this bid, here we go. And this bid will have blinded bid that will be equal to blinded bid. So our hash. And it will then have our deposit, and this will be equal to the value that is sent by the user here. So simply bid allows us to store the hashed value inside of our mapping. Okay. Now, next one is the auction end. So this is what will allow us to say the auction is finished. And from that moment, we can actually reveal everything. So, auction end. So, what this is going to do is not going to take any arguments, but it's going to be a public function. So, it's accessible outside. And it's going to be a payable. And it will be available only, not before, only after reveal end. So first thing that we're going to do is we're going to require that ended is false, right? So it is not ended. And we're going to do straight away emit. So we call our event that we created. So it's our event auction ended. And we're going to pass values that are highest bidder and highest bid, just to register this information inside of the blockchain. And we're just going to say that ended equals true. So now we officially say that the auction is finished. And then we transfer the amount to the beneficiary. So beneficiary, because we saved this the beneficiary's address in our constructor, beneficiary.transfer, and we're going to transfer the highest bid amount. And that's it. This is our auction end. It's simply make sure that we did not already end the auction. It's going to log these values to the blockchain, and then it's going to transfer the highest bid to the beneficiary, simply before that making sure that we set this value to true, so that next time this is called, it won't work. Okay, and now, finally, what we're going to be looking at now is the place bid function. So place bid is once the bidding time is over, then we can go and reveal all of the bids that happened. And when this is happening, this is the moment where the transactions will actually happen and everything will be visible in the blockchain. And what we need to do at that point is actually place the bids. Yeah. So in this, basically, what we're going to take is an address that will be the address of the bidder. And we're going to also take a uint that will be value. And this function is only internal. We're not going to let it be called from outside because this is only triggered within the reveal function. And I forgot one thing. This is going to return just a Boolean that tells us, whether it was successful or not. Okay. Now, the first thing that we need to do is we want to make sure that if the value is smaller or equal to the highest bid, then we return false, because the value has to be equal, has to be greater, we only accept new bids that are higher than the highest bid, because otherwise it's useless transactions. We don't need to do that, and it's even more information exposed. So the only transactions that we actually take are the ones where the value that is being bid is greater than the highest bid, obviously. And if it's not the case, then return false and it's the end. We don't place this bid. Instead, something else will happen. It will be added to our mapping, that the pending returns mapping that allows users to just get their money back. Okay, so then we're gonna just add another if that verifies. So if space if the highest bidder, which is the address of the highest bidder, is different than address 0. So address 0 is the 0 address. It's the address that looks like 0x000000. It's the address that, part of this contract, we would send some coins to in order to burn them. It's not an actual address. It will definitely not be the address of the highest bidder. Therefore, we just verify this. And if it isn't, well, then in that case, we're going to say pending returns highest bidder, and we're just going to add highest bid. Right? So if we have a new higher bid, in that case, we're going to simply add the previous value of the highest bid to the pending returns value, so that this person will be able to claim and withdraw these coins back. So that's it, part of this if. And once this is done, we're simply going to say highest bid is now equal to the value, and highest bidder is now equal to the bidder. And that is it's easy. We set the bidder, so the new address, and value, the new value. And we're simply going to return true. So if it fails here, it will return false straight away as part of this Boolean. And if it goes all the way down, it returns true, and it's done. Okay, so that's it for today's video. In the next one, we're gonna look at the reveal function. It's the last one we have left to do. This is what is gonna basically take all of these logics together, the auction and the place bid, and also decipher the values that we saved into our bids mapping. and then we're gonna go ahead and test this together. So hope you enjoyed it. I'll talk to you in the next video. Until then, take care.